This is the final lesson. We're going to implement the app logic to randomize the cards whenever we tap on the deal button, and we're going to update the scores as well. By the end of this lesson, you're going to have a working war card game. All right, let's dive in. Let's do a quick recap of what we have so far. When we tap on the deal button, it prints out this deal cards statement down here, but what we actually want to happen is to randomize and display two new cards right here, right? Let's dive into the code for the button and let's go from there. So we're going to scroll down, and this is our view code right here. You can see this is our button element, and when you tap on it, it calls this function deal. If we scroll down a little further, you'll see this is where we've defined it, and it prints out the cards. Now, what we're going to do is delete this statement, and I'm going to add something that's called a comment, or some people will call it documentation, but essentially it is a little reminder that you can leave yourself that is not treated as code. So Xcode, as you can see when I type this, will treat it as this grayed out text, and it's not going to be treated as code. You can just leave yourself as many notes as you want. And it's a good way to also write out the things that you're going to code. So we can say randomize the player's card, randomize the CPU's card, and we are going to, let's say, update the score. Right? That's essentially what we want to happen. When we tap on this, we want to change the cards. Depending on who wins, we are going to update the scores down here. Let's take a look at how we are going to change the cards up here. We scroll up a little bit and we take a look at our view code. We can see that we have an image element representing the player's card right here, and another image element representing the CPU card. You can see the card that is shown is driven by these two variables up here, player card and CPU card. Scroll up here, that is exactly where these things are. This string card 7 represents that. This card 13 represents that. And these are two variables. Now, one thing I haven't taught you yet is something that's called a struct. This is sort of an aside. So you don't really need to know this yet, but in the next module, we'll talk about what a struct is. And these are actually what you know as variables when they are declared inside a struct like this. This is actually also called a property, but we will get there later. So for now, you can think of them still as variables. Now, I want to point out one thing. If you notice the way that we've named these card assets here, we go into our asset library, they all have the word lowercase card followed by a number from 2 to 14. And the reason why I named it this way is because it's going to make us really easy to randomize and choose new cards when we tap on the deal button, because all we have to do is, let's say we wanted to change the player card, right, is represented by this variable right here. All we have to do is change this to card and then a random number from 2 to 14. And there is a function, a built-in function that we can use that would randomly pick a number from whatever range we want. So I'll show you how to do that. But essentially, when we tap on the deal button, all we're going to do is assign card, the string, followed by a random number from 2 to 14. And we're going to do that for player card and CPU card. And when we change the strings in these two variables, it is automatically going to be picked up by this image element here, these two image elements, and then you'll see new cards. All right, so let's go ahead and do that. So we're going to go back down to the deal button here, and let me show you what we want to do. So first of all, player card, right? So player card equals, remember this is referencing the variable up at the top. Equal is we're going to assign something new into it. We're going to type in this word, the string card, and then we are going to attach to it a random number from 2 to 14. Now we can use the plus symbol to join together two strings. So I can do something like this, right? And that would essentially be one string, card 7. This is called string concatenation. Right? Ignore the error for now. Now, I don't really want to put 7, right? I want this to be a random number. So instead of attaching the string 7, I am going to type in int dot random. Right? When you do that, capital I dot and an R, you're gonna get this. And we're going to use this first one right here, this first function. And this is going to allow us to specify a range. And how we specify a range is we put in the lower range followed by 3 dots and then the upper range. And this will be inclusive of the lower and upper ranges. So essentially this function, this random function of int gives us 2 to 14. Now you won't understand exactly what this code means for now, but in the next module, after I teach you about structs and classes and things like that and dot notation, this will completely make sense to you. For now, just type in int, capital I int dot random, and then type in this range. Now you're going to get an error here. And the reason why this error is occurring is, for one, there's 2 errors here actually. The first error is because when you're trying to do that string concatenation I was telling you about, it has to be 2 strings. Right here we have the card string, but here we have an integer data type. They're different data types. Remember way back then you learned about data types, how we have string, int, bool, double, and things like that? Well, this random number is actually an int. So what we can do is get the string representation of the int. Essentially, we are converting, or the proper term in app development and programming is called casting. We're going to cast the int data to a piece of string data. So then it becomes the right type. And we do that by typing in string and then wrapping the int in a pair of parentheses right there. So now this would actually be proper. And this now is actually another error. So now you can see that the error, that little red underline, is on the variable player card. So remember, if I scroll all the way back up to the top, remember how I said that when these variables are declared under the struct like this is called a property. Well, we're going to learn more about structs and properties in the next module. But what we need to do here is essentially add a special keyword to this property or variable to define it as something that powers the user interface. Like it's a piece of data that the user interface depends on. And that totally makes sense, right? If you look down here, this image element right here depends on player card. Same thing with this one. This image element, which is, visually represented here, it depends on the state of this variable or property right here. So depending on the state of these 2 variables, it changes how the user interface looks. So what we have to do is add a special keyword in front of both of these called state, right? And the way we specify this is using the @ keyword, capital S, state, space. So you can see Xcode recognizes it as a special keyword, and this is called a property wrapper. So this is your property, and this is the property wrapper. And it essentially changes the behavior and attributes, kind of like a modifier. It modifies this property to just indicate that it is a special property, right? It is one that powers the visual state. So we're going to add the same keyword or property wrapper to the CPU card down here. And then if we scroll down back to the deal button, you can see that all the errors are gone. And we're going to randomize the CPU card as well. Card plus, and then we are going to say int random 2 to 14. Right? And then we're going to have to, I'll show you this error because last time I don't think we took a look at it. So here, cannot convert value of int to expected type string. It's saying that this should be a string. So we're going to turn it into a string. All right, no errors. Perfect. So let's take a look at this. We'll run it and we'll try it out because we should be able to visually see these cards change. As we tap on this deal button, it's going to run this function. It's going to assign a random card number, 2-player card, and then CPU card as well. So you see that's really cool, right? It's actually working. Now, if you accidentally specified a number that doesn't exist, like these actually have to represent an image asset. So if you put 15 and you hit deal and it randomizes the 15, it either will show a blank. Let's randomize from 1 to 1 and you can see what I mean, because we don't actually have card 1 here. So it's going to be an error. It's not going to be valid. We have to stop the project and run it again. And yeah, there you go. It can't find that image because randomizing 1 to 1, you're only going to get card 1, and there is no image asset named card 1. So just a little warning for that. Okay, so let's change that. Command R to run it again. Now we get this. Okay, now we need to add some conditional logic to the app. This means code that can decide if this condition is true, then do this. Otherwise, if that condition is true, do that. And in Swift, this is called an if statement. Let me show you how. So here I have an empty playground to show you how simple it is to express conditional logic in Swift. And all you have to do is use the keyword if. Just like that. And next, you're going to put a space, and then you're going to put the condition that you want to test. Now, with an if statement, it is if the condition is true, then execute this code. And if it's not true, then don't do anything. So why don't we say if A is greater than B, that's my condition. So if that is true, then execute the following code. And you put that code inside a pair of curly brackets like that. So I'm going to write a comment, some code here. Like it's whatever you want, as many lines of code as you want. You can even call a function here or do anything like that. So we are simply going to print, let's say, bang. Now, what is A and what is B in this condition? We haven't declared them. So let's declare two variables. So var A equals 4, var B equals 5. So actually, why don't we make B shorter or smaller? So this condition becomes true, right? A is 4, it's greater than B is 2, right? That is true. So this will get executed. It will go into this code block. Let's run the playground and see if that actually is true. Let's click this button to open up the console. And you can see that it gets printed out right here. Now, what if I changed B to 20? And let's stop the playground. Let's run it again. And you'll see that this time nothing gets displayed because it comes down here and it tests this condition. It finds out this condition is false. Then it's not going to run this code. Now, the powerful thing with if statements is that you can specify multiple paths or multiple branches. So if you think about this condition and this block of code being one path that it could go down, you could also specify another. You could say else if, and again, you specify the condition here and then another block of code. So let's say if, if B is, let's use another variable. So let's say if B is greater than C, then do this. So we'll print shoot. We don't have a C yet. Let's put a C there. Let's put C is equal to 10. So in this case, what's going to happen? It's going to first execute this, right? And is it going to be true or false? A is 4, B is 20. This is false. Then if this is false, it's going to skip this and it's going to test this else, right? Else means like, okay, if that's not true, then what about this, right? Else, if this is true, B 20, C is 10, it is true. So it's going to then come in here. So it does this instead. Now, what if C was 30? Let's run it. Can you guess what happens? You can pause the video and take a guess if you want. Nothing happens. Why? Because it comes in here. This is false. Okay, well, let's test this one. This is also false, so it doesn't go into either path. Now, what happens if I did this? What if C is 10, right? So it's gonna, this is false and this is true, right? It's gonna come in here. But then I change A to 40, right? So this becomes true. Do you think it's gonna type out bang and then type out shoot? Nope. It's only going to take the path that is true, the first path that is true, and it checks the conditions from top to bottom. So it tests this one. Oh, that is true. 40 is greater than 20, so it's going to come into this path and it's going to ignore everything else. It's just not going to even check the other paths. So that's why you have that, even though both of these conditions are true. So the thing is, you can specify more branches if you'd like. You can do else if as many different paths as you want. And then there is also a catch-all, or sort of like a last resort path if you want to do that. And that is just simply else. So if this is not true and this is not true, then it's just going to execute this, whatever's in here. So if I run this, it's going to come in here because this is true. So let's change A back to 4. So this is going to be false. Right, 4 is not greater than 20. And then let's change C to 40. So again, this will be also false. 20 is not greater than 40. And so it's going to come down here and it's going to execute this. And this is sort of like a last resort. And you could have something like this. The else, if, and else, these two clauses are completely optional. You can only have one else catch-all path, but you can have as many else if paths or branches that you'd like. So in this case, it would execute hello. Because this is false, then it just comes down here. So hopefully that makes a lot of sense, pretty simple to understand. And in terms of testing for equality, here's greater than, there's less than, and then you can do less than and equal to, or greater than and equal to. You can do not equals, that's exclamation mark equals. And if you want to test for equality, it's not equals, because remember, the equal symbol is for assigning something to something. So here we're assigning 4 to A, we're assigning 20 to B. So here we're not trying to assign B to A, we're just trying to test if they're equal. If you're trying to test if two things are equal, you use equals equals. Like that. And so if we make A equal to B, so that will be true, we'll see bang. All right, now let's apply our newfound knowledge to the war card game. Let's do it. So back in our war card game, in the deal function here, we want to update the scores. So we can use if statements. We want to say if the player's score or card value is higher than the CPU card value, then we want to increase the player's score. Else, if the CPU card or card value is greater than the player card value, then we want to update the CPU score. And if you scroll all the way back up here, you'll see that we have two properties, variables, keeping track of the player score and CPU score. So we're just going to increment this by 1, depending on whose card value is higher. So going back down here, we're going to use the if statement, if, and then we're going to compare player card value with CPU card value. And how do we get the card value? Because if you take a look at this, we're randomizing the number here. I've strategically chosen the numbers so that they represent the card image asset, but they also represent the card value. So down here, card 2 is smaller than any of these numbers, right? So ace, that's why I made it 14, because ace should be the biggest. So if someone randomizes an ace, that would be 14, and that would beat 13, which is king. So what we need to do is to be able to compare this random number with this random number. So we need a reference to it, right? But how do we get a reference to that number? Because I've specified it here, and it's going to get joined together with this card. So I can't actually refer to it. So the strategy we're going to use is to, instead of randomizing it here, let's randomize a number from 2 to 14 and assign it to a variable. And that way we have a reference to it, right? It goes back to that first Swift coding lesson you did a couple lessons back about using variables to keep track of values. So here we are going to declare a new value. Let's call it player card value. And we are going to assign to it this. Right, so we're going to randomize that number from 2 to 14 and we're going to assign it into this variable. And then in here we can specify that variable right there, right? And turn it into a string because this is an integer, right? That's going to get assigned to this. And then we're going to do the same thing with this. CPU, var CPU card value is equal to CPU card value. And then we're going to now be able to write our if statement. So if player card value is greater than CPU card value, then we are going to add 1 to player score. And to do that, we can say player score, and that's the variable that we have way up at the top of this file. We can do this, we can say equals player score plus 1. But there's a short form way you can write this, which is this, plus equals 1. And that is just going to increment whatever score it is with 1. Okay, so we're going to do it the shorthand way. And just like before, we have an error because remember, player score is a piece of data that the user interface is dependent on, right? It gets displayed in this text label right here. You can see right here, this text, and this text right here. So what we have to do is add that state property wrapper to it, just like we did with the player card and the CPU card. All right, now we're going to come back down and no error. So down here, would I add an else or an else if I want to now compare, right, if the CPU card value is greater than the player card value? Now I could use if, and I can say, you know, in that case, CPU score would plus equals 1. But there's a problem with this because this is comparing player card is greater than CPU card. What if player card value equals CPU card value? What if they rolled exactly the same value? In this logic, the CPU would win even if the values were tied up, right? So I would not use else here. I would use else if CPU card value is greater than player card value. And then you can say else, this is a tie, right? And then you can handle this how you want. So in this case, this would be like add 1 to CPU score. You see how handy adding these comments are? It really makes it a lot easier to understand your code, especially for someone who is new and learning how to code. Yeah. So for this tie scenario, you can add 1 to each score, you can minus 1 from each score, or you can do nothing. So I'm going to choose to do nothing, but you can do that differently. So let's see if this works. Let's run our project. Oh, what happened there? I rolled a card. Take a look. I made a mistake. This is a perfect learning opportunity. So, right here, player card is equal to card plus player card. But that doesn't make sense, right? It should be equal to player card value, right? Because this is the random number. So I don't know if you caught that earlier on when I was writing that, but if you did, kudos to you, props. But if you didn't, then you're in the same boat as me. I totally didn't see that either. So you can see it works now. Well, I'm going a little fast, but ace. So player gets that. Oh, it's a tie. See, there's a tie, so nothing happens. All right, looks like it's working. And there's actually more ties than I thought there would be. There was another one. And there you have it. You've built your very first app. Now, before I tell you what you'll be building next, let's do a quick recap of how far you've come. You learned your way around Xcode and how to use it to build app user interfaces, and also how to express logic with Swift code. You also learned how to translate an app design into a user interface and how to handle user interaction with buttons, and you learned some basic Swift coding. So where do you go from here? Well, in the next video series, I'm going to be teaching you how to build this, and what are the different components of an app and how do they talk to each other to make the whole system work. We're going to be diving down into more detail about that. Now, although this next video series is also free to learn from, it's going to be only hosted on our CodeWithChris learning platform. All you need to do is create a free account and you'll get access to it. Simply click over here for instructions on how to get Module 2, and I'll also leave a link in the description below. You're doing an amazing job so far. I can't wait to see you in Module 2, where we're going to take your skills even further. I'll see you there.